Number 24. Consider the following mechanism for the reaction represented above. So we have this reaction right here, which apparently happens in two different steps, and it looks like slow step is the second step, step 2, and as everybody should remember, slow step is basically the rate determining step, right? Because that determines the overall rate of reaction, how fast it can go. So which of the following statements is true? So this question was actually quite difficult because the right answer wasn't like super clear for everybody to kind of see. So I'm just going to go through the process of eliminations, and I know the answer is D, so I'm going to go through A, B, C first, and then prove it to you why they're all wrong. Answer choice A. Step 1 represents a unimolecular reaction. Absolutely not, because that's nitrogen monoxide plus nitrogen monoxide. That's not unimolecular. That's actually two molecules going on. So that's not uni, aka one molecular reaction. That's absolutely false. Part B. Increasing the concentration of NO will decrease the overall rate of reaction. Well, first of all, that's absolutely false for two different reasons. If you increase the concentration, the rate of reaction normally increases, right? Remember, like, so there's some factors that increase the rate of reactions, right? And increasing concentration is definitely one of them. So if anything, you should increase it. Now, the second part that is really wrong with this is the fact that it decreases the overall rate of reaction. Well, it wouldn't increase or decrease because, once again, that nitrogen monoxide is part of your fast reversible reaction. The fast reaction does not determine the overall rate of reaction. Remember that. It's the slow step that determines the overall rate of reaction. So I don't care if you increase the concentration or decrease the concentration. It should not increase the rate of the overall reaction. It should not decrease the rate of the overall reaction. It should not do anything to the overall rate of reaction. That's why this is wrong. But like I said, even if it did something, if anything, it should probably increase the overall rate of reaction, not decrease it. It actually made zero sense, which is why that was so false. Part C, raising the temperature will have no effect on the numerical value of the rate constant. That's absolutely false. In fact, this little small k value, the rate constant, or this big K value, we call it equilibrium constant. These two actually could change only under one condition, and that condition is when you change the temperature. Because remember, people, temperature is a measurement of kinetic energy. The fact that you increase the temperature means you have more kinetic energy, so the molecules have more energy to move around, and therefore the reaction is going to happen faster. So in fact, that will alter the K values. I don't care whether the rate constant, small k value, or the equilibrium constant, the big K value. Those are called constants, rate constant, equilibrium constants. So the word constant means it doesn't change. Now, once again, it doesn't change only except under one condition, and that one condition is changing the temperature. So if you do change the temperature, the K values do change. So this is why that's wrong. So now part D says the rate law is consistent with the mechanism. Rate is equal to K times the NO to the second order and then O2 to the first order. Now, that looks like it just straight up took the coefficients in the overall reaction, which is not normally how you do it, right? Remember, peeps, if you do your equilibrium constant calculations, yeah, you just simply take the coefficients and put it to the powers. When you're doing the rates, you don't really do that. You actually have to calculate the orders by, looking at the changing concentrations versus the overall rate of the reaction. So let's just hypothetically say, well, the fact that this is saying it's second order to the nitrogen monoxide means if you double up the concentration of nitrogen monoxide, well, your overall reaction should quadruple, right, in terms of how fast it goes. So that's what it means to be second order. Now, you can't just simply figure that out by looking at the overall reaction and just simply taking the coefficient. It doesn't work that way. So it wasn't very clear for you to see, but because the other three choices absolutely make zero sense, that's why the answer choice D had to be correct. Now, once again, this is a very hard question because just by simply looking at the overall reaction like this simply does not tell you the specific orders for every one of your reactants. So this was a quite hard question in my opinion.